this video, we will focus on redox reaction. What you will learn in this lesson: what oxidation and reduction are, explain what redox reaction, explain what oxidizing agent and reducing agent are. We can define oxidation and reduction reaction by using 4 different criteria. The first criteria, gain or loss of oxygen. The second criteria, based on the loss or gains of hydrogen. The third criteria that we can use is based on the loss or gains of electron. And lastly, the increase or decrease in the oxidation number of an element. Let us look at the oxidation and reduction in terms of gain or loss of oxygen. Oxidation is a chemical reaction in which oxygen is added to a substance. So if a substance, normally elements or compound, gains oxygen during a reaction, it is said to be oxidized. On the other hand, a reduction reaction is a reverse process of an oxidation reaction. Reduction is defined as the loss of oxygen from a substance. So if a substance lost oxygen during a reaction, it is said to be reduced. Oxidation in terms of gains of oxygen. Let's look at example 1. When magnesium burns in oxygen, the following reaction occurred. This is the chemical reaction showing magnesium burns in oxygen to form magnesium oxide. As we can see in this chemical equation, magnesium atom gains oxygen to form magnesium oxide. So we call this process an oxidation process. Magnesium is oxidized to magnesium oxide because it gains oxygen in this reaction. Example 2. Methane burns in air as represented by the equation below. Methane burns in oxygen will produce carbon dioxide and water. So in this reaction, we can see here methane gains oxygen to form carbon dioxide. So we say methane is oxidized. At the same time, hydrogens in the methane molecule also gains oxygen to form water molecule. So again, methane is oxidized to water because methane gains oxygen. Therefore, combustion of methane is an oxidation reaction. What is a redox reaction? The word redox is a combination of reduction and oxidation. A redox reaction is defined as a reaction in which both oxidation and reduction take place simultaneously. That means occur at the same time. So in a redox reaction, when a substance is oxidized, another substance is reduced. The second criteria, oxidation and reduction in terms of gains or loss of hydrogen. Oxidation can be defined as a loss of hydrogen from the substance. On the other hand, reduction can be also defined as the addition of hydrogen to a substance. Criteria number 2, oxidation in terms of gain of oxygen. Example 4. When hydrogen sulfide gas is mixed with chlorine gas at room temperature, a yellow precipitate of sulfur is formed, and hydrogen chloride gas is released. Let's look at the chemical equation that represent the reaction above. As we can see in this equation, hydrogen sulfide lost hydrogen to form sulfur. So we call this reaction an oxidation reaction. At the same time, chlorine molecule gains hydrogen. So we call this reaction a reduction reaction. And we can see here oxidation and reduction occur simultaneously in this reaction. So we can say this reaction is a redox reaction. Example number 5. When ammonia reacts with bromine, let's look at this chemical equation. Ammonia lost hydrogen to form nitrogen gas during this chemical reaction. So ammonia undergo oxidation. On the other hand, bromine gains hydrogen to form hydrogen bromide. So bromine undergo reduction. And this is an example of redox reaction. Oxidizing agent and reducing agent. Oxidizing agent and reducing agents are referred to the reactants used in a chemical reaction. So which reactant act as oxidizing agent? Oxidizing agent cause oxidation in another substance. Reducing agent cause reduction in another substance. At the same time, oxidizing agent itself will undergo reduction, and the reducing agent will undergo oxidation. Let's look at example 3. In this reaction, zinc is oxidized to zinc oxide because zinc gains oxygen. Copper 2 oxide acts as an oxidizing agent because copper 2 oxide oxidizes zinc to zinc oxide by donating the oxygen to zinc oxide. And zinc now acts as an reducing agent because zinc had reduced copper 2 oxide to copper. Let's look at example 4. Hydrogen sulfide gas is mixed with chlorine gas at room temperature. So in this equation, we can see that hydrogen sulfide is oxidized to sulfur, and the chlorine gas is a substance that causes hydrogen sulfide undergo oxidation. So we call chlorine as oxidizing agent. On the other hand, chlorine undergo reduction because hydrogen sulfide causes chlorine to undergo reduction. So hydrogen sulfide acts as a reducing agent. Criteria number 3. Oxidation and reduction in terms of gain or loss of electron. Oxidation can also be defined as a loss of electron from a substance. Reduction can also be defined as the addition of electron to a substance. Let's look at this diagram. Substance A lost electron or donate electron to substance B. So substance A undergo oxidation. At the same time, substance B receives the electron from substance A. So substance B is reduced. So substance A causes substance B to undergo reduction. So substance A acts as a reducing agent in this reaction. And then substance B is the substance that causes substance A to undergo oxidation. So substance B is an oxidizing agent. Example 5. Magnesium burns in oxygen. We can rewrite the chemical equation using two-half equation. Magnesium atom lost electron in this reaction. So magnesium undergo oxidation. Oxygen molecule gains 4 electrons to form 2 oxide ions. So oxygen molecule gains electron. Oxygen undergo reduction. Magnesium here acts as a reducing agent because magnesium causes oxygen to undergo reduction. On the other hand, oxygen acts as an oxidizing agent because oxygen causes magnesium to undergo oxidation. This reaction is an example of redox reaction. Example 6. Zinc reacts with copper 2 oxide. Zinc atom lost 2 electrons. So zinc atom undergo oxidation. Copper 2 ion receive 2 electrons. So copper 2 oxide or copper 2 ions undergo reduction. Zinc acts as a reducing agent because zinc had reduced copper 2 oxide to copper. Copper 2 oxide acts as an oxidizing agent because copper 2 oxide oxidizes zinc to zinc ion.